Do you wish to look back in time? It's very easy. All you have to do is look up at the night sky. The night sky is like a time machine. The deeper you look into it, the farther backward in time you see. But how is that possible? How is looking at a star equivalent to looking back in time? Stay with me. When you look at the stars with naked eyes, you're looking at the light they emitted. Light is nothing but an electromagnetic wave. In fact, our eyes are sensitive to a very narrow part of the spectrum that extends all the way from gamma rays to X-rays, UV rays, the visible region, infrared rays, microwaves, and finally radio waves. For a long time, it was believed that light travels at an infinite speed. But in the 17th century, old Romer calculated the speed of light using Io, a moon of Jupiter. It was one of the first recorded experiments that determined the speed of light. Today, we know that light travels at 300,000 kilometers per second. So the fact that the night sky is like a time machine is because light travels at a finite speed. At 300,000 kilometers a second, light covers a distance of nearly 9.6 trillion kilometers each year. This distance is what is called a light year. This term is a bit misleading. It might sound like a unit of time, but it's a unit of distance widely used in astronomy. Different branches of physics require different units for convenience. For astronomical purposes, it's inconvenient to use SI units such as meters. The nearest star to our Sun is Proxima Centauri. It lies 4.2 light-years away. This means that light took 4.2 years to cover the distance between the Earth and the star. So when we look at the star, we actually see how it appeared 4.2 years ago. Similarly, the Sun is 500 light-seconds away. The light takes 500 seconds to travel from its surface to Earth. So if a massive flare erupts on the Sun, we would only see it after 8 minutes and 20 seconds. Even worse, in a hypothetical scenario, if the Sun disappears, we will continue to receive sunshine for 500 seconds. And the Earth will keep traveling in its elliptical orbit for the same period. Only after 500 seconds would its orbit and trajectory change, because even gravitational information travels at the speed of light. Even the reverse is true. Suppose there's an intelligent civilization about 100 light-years away, and they developed the technology of radio broadcasts like us. In that case, they can tune in to our first radio broadcast that began about 100 years ago, because even radio waves are electromagnetic waves that travel at 300,000 kilometers per second. At the right frequency, people around that region would be listening to what was happening on Earth 100 years ago. For example, they would be learning that Einstein's theory of relativity has been proven correct, or the medal summary of the 1920 Summer Olympics held in Belgium. Let's go even further to one of the nearest galaxies to our Milky Way, the Andromeda Galaxy. It's the biggest galaxy of local group and can be seen with naked eyes under perfectly dark skies. Andromeda is 2.3 million light-years away. So just like I mentioned before, not only are we looking at the 2.3 million years old Andromeda Galaxy, anyone living on a planet in that galaxy who can see the Milky Way would be looking 2.3 million years back in time. So if they have a hypothetical telescope that can look at what's happening on the Earth, they would not be looking at us. In fact, they would be looking at the first humans that emerged in Africa 2 million years ago. If anyone living about 67 million light-years away can see what is happening on Earth at present, they would be seeing dinosaurs walking our planet. That's how the night sky is like a time machine. The James Webb Telescope will mainly work in the infrared region of the electromagnetic spectrum. Since infrared waves have a longer wavelength than visible or UV rays, they can easily penetrate thick interstellar clouds and dust. Hence, Webb can see those regions of the cosmos that remained out of Hubble's reach. Webb has the potential to reveal the universe as it was in its cradle. For decades, the quest to see the birth of the first stars and galaxies has been a holy grail in astronomy. Since we are made of stuff once processed in the cores of giant stars, it's like searching for our own origins. If you're interested in studying astrophysics at home, make sure to check out our Basics of Astrophysics series, the link to which is given in the description. This series explains everything at the most fundamental level, from the EM spectrum to telescopes, and from the birth of stars to the formation of black holes and galaxies.